Okay, folks, that's it for lesson 7.2.4. Let's jump now into lesson 7.2.5. The title of this lesson is simply two-column proofs. Sounds easy enough. By the way, this is modified from the core problems in the book. All I'm going to do is two proofs. That's it. And we're going to use this new style proof called the two-column proof. And if you talk to ancient people such as myself, this is all I remember doing in high school geometry was two-column proofs. And you have a little bit of a jump start because we've been doing flowchart proofs like this guy over here. We've been doing flowchart proofs for the last couple months. A two-column proof is just a flowchart proof reformatted. So if you understand flowchart proofs, you're in good shape. If you don't understand flowchart proofs, well, here's another way that might make more sense to you. Okay, we're going to start with this problem. I've labeled it here as number 4. If you look back, it's exactly like problem number 3. We have already looked at this proof, and we stepped through that in the previous lesson on side page 1. And all I'm going to do here is show you how to construct a two-column proof based on a flowchart. Okay, so we're going to start like this. We're going to put statements on the left, and we're going to put reasons on the right. Okay, next thing I want to say is, do you remember how I've been encouraging you to write these little things next to each of your fact ovals in a flowchart, the little reasons why each of those things was true? Well, the reason, it's a reason. It's going to become part of our flowchart proof now. So that's why I've asked you to start doing that over the last couple of weeks. So let's go ahead and take a look at this first two-column proof. The first fact we have is that ABCD is a rectangle. And what's the reason that we're allowed to say that? Well, that was given. So right away, we have this first fact oval taken care of. Now for the second statement in this proof, we do kind of have some choices here. First of all, if I look back at this flowchart, I really can draw this first given piece of information really arrows down to those two fact ovals as well. In fact, now that I formally think about it, I don't even think that line there is necessary because that piece of information stands on its own. So what I'm going to do next is say my second statement will be that angle ADC and angle BCD are right angles. Why am I allowed to say that? Well, because that's the definition of a rectangle. A rectangle is a quadrilateral with 4 right angles. So boom, we've taken care of that fact oval. Now let's go ahead and make the statement that segment DC is congruent to itself. Fancy name for that is the reflexive property, but you may also hear it as shared side. Boom, we've taken care of this fact oval. We are cooking with gas now. Let's go on to number 4. The fourth statement I'm going to make is that segment AD is congruent to segment BC. What is the reason that I'm allowed to make that statement? Well, I know that opposite sides of a parallelogram are congruent. Just like that, bam, I've taken care of another fact oval. I'm now ready to make a statement about triangle congruence. That's going to be my 5th statement. Triangle ADC is congruent to triangle BCD. The reason that we can make that statement, well, that's side angle side congruence. Bam! We've taken care of another fact oval. Let's go down to our 6th and final statement, and that is that segment AC is congruent to segment BD. What's our reason? Congruent triangles have congruent parts. If you prefer, you can call that CP, CT. Folks, pat yourself on the back. You just did your first two-column proof. And again, I'll reiterate, it is no different than the flowchart proof. Oh, I forgot to do this. Bam! We got our final fact oval and we're done. So it is no different than a flowchart proof. It's just a different format. And the good thing is you have choice. You do whichever one you prefer. Okay, let's go down here to the fifth and final problem here. It says given point P is on the perpendicular bisector. Oh boy, there's a big word right there, perpendicular bisector. Given that point P is on the perpendicular bisector of segment AB, we have to prove that length PA equals length PB. The perpendicular bisector is one of my favorite things in geometry because you get two pieces of information for the price of one. We know that perpendicular means that things intersect at right angles, and we know that bisector means that a segment is cut in half, cut into two congruent pieces. Okay, so I want to show you why I'm proving this to you, and I'm going to flip back to the org chart. Take a look down the bottom right-hand corner of the org chart. I mentioned that there were a couple miscellaneous things that fit into this chapter, and this is one of them. We have definition here for a perpendicular bisector and then a feature. For a feature, I better prove that. So that's what we're doing right now, proving it with a two-column proof. It's going to take us 6 steps. Now, there's no magic number for steps in a proof. It just happens to be that this one's going to take us 6 steps. And what we're trying to prove is that these two segments right here, we're trying to prove that those are equal. And we're going to do that through congruent triangles. So let's see how that's going to work. First, we start with the given information. Upside down T is the symbol for perpendicular, by the way, so I'm going to abbreviate it there. Given. Bam. Step 1, statement and reason are done. Step 2. This is already shown in the picture. Segment AM and segment BM are congruent. Sometimes I say that segments are congruent. Sometimes I say that their lengths are equal. Those two things are equivalent. Well, that's the definition of a bisector, folks. If a segment is bisected, it's cut into two congruent pieces. Okay, so bam, we're done with statement 2 and reason 2. Let's go on to number 3. So now I'm going to say something about angles here. I'm going to say that angle AMP and angle BMP are right angles. Well, that's the definition of perpendicular. Bam! We're done with statement 3 and reason 3. Let's move on. Hey, take a look at this. There's a segment, PM, that's in both triangles, the triangle on the left and the triangle on the right. And if I didn't already mention that, we're going to get to our final result through congruent triangles. So I got segment PM that is congruent to itself. That's our friend, the reflexive property, or shared side, your choice. And just like that, bam! We are done with statement 4 and reason 4. Let's go on to number 5. Do you see we got two triangles that are congruent there? Triangle APM is congruent to triangle BPM, and that's by side angle side congruence. We got a pair of sides that are congruent in the triangle on the left and the right. We got the shared side between them, and then sure enough, we have pair of right angles that are congruent between those sides that are congruent. So we have triangle congruence by side angle side. We're now ready for the 6th and final statement, and that is what we were trying to prove to begin with. PA equals PB. Why? Because congruent triangles have congruent corresponding parts. And you know it. Bam! That's statement 6 and reason 6 are done. Couple comments here about two-column proofs. The given information, which I'll highlight here in yellow, the given information is almost always the first statement and first reason of the proof. The thing that you're trying to prove is always the last statement of the proof. All you really have to come up with, and I know this is the hard part, but all you really have to come up with is the following. So at a minimum, you ought to be able to get some credit by including the given information as well as a reason, and then the final proof as a statement. Another thing I want to mention here is I alluded to this before. I said sometimes I just say that lengths are equal, and sometimes I say that segments are congruent. A geometry purist would take issue with me flipping back and forth like that. But I will tell you, for the purposes of what we're doing in geometry, I'm okay if you use either the congruent symbol when you're talking about segments that are the same length, or whether you use the equal symbol. I'm okay either way. Okay, last thing I want to do is I want to show you this this new feature that we just learned about. I want to show you this in motion. So yeah, we've got it on the org chart here. We got the definition of a perpendicular bisector, and we now know that feature, that all points on the perpendicular bisector are equidistant from the endpoints of the segment. So I showed you that in a proof. Now let me show you what that looks like dynamically. So I've got a construction here. I've got segment AB. I'm going to move it around. I found the midpoint here, and then I ran the perpendicular bisector through that. You'll notice that the segment on the left and the segment on the right are marked as congruent, and then I got my right angle marked there because it is a perpendicular bisector. So what we were asked to prove is that any point on this line is the same distance from the endpoints of the segment. So that means that right now PA should equal PB. If I move it down here, the same thing will be true. Yeah, there'll be different lengths, but they'll be a different length than the first time, but they will be equal. So let me go ahead and show that to you. Okay, so watch what happens here. As I move point P along this line, this distance, this dynamic number right here, is the actual length between points P and A, and the length from P to B. And you'll see that no matter where I move that point, those two numbers stay the same. What happens if I flip it down here? Same thing is true. What if I were to change the segment and kind of maybe move points A and B around? Does the same thing hold true? It sure does. It doesn't matter where segment AB is located. If a point is on the perpendicular bisector of that segment, it is equidistant from the endpoints. All right, folks, that's a wrap on 7.2.5. Next thing you ought to be looking at is review preview for 7.2.4 and 7.2.5, and hit me up with questions. Thank you.